Hi, I'm Chris D'Souza. Today I'm going to talk about SSB, SSW, and SST with respect to k-means clustering algorithm. SSB refers to sum of squares between clusters. SSW refers to sum of squares within clusters, and SST refers to sum of squares total for all clusters. K-means clustering algorithm expectation is that all data points within a cluster are close to each other and points between clusters are distant from each other. SSW is a measure of the distance of the data points within all clusters, and a low value of SSW indicates that points in that cluster are close to each other, which is a feature of good cluster. Whereas SSB is a measure of the distance between clusters. A high value of SSB indicates that the data points in different clusters are distant, again indicating a good clustering mechanism. This figure illustrates SSW and SSB conceptually. Assume we have got three clusters shown by three bell-shaped curves. Each cluster will have a center, and the distance from which is represented by letter C in this figure, and the distance from the center to all points in that cluster should be as small as possible. And if that is the case, the total sum of the distance for all such clusters from its center to all the points within that cluster should be as small as possible. In other words, the value of SSWs should be minimal. On the other hand, SSB is the sum of the distance from the center of each cluster to all the data points in that center. The sum of the square of the distance from each data point in the system to the overall mean is called the SST, or the sum of squares total. We will use an example to illustrate these values. Here we assume we got two clusters shown in red and black, and each cluster has got 3 data points. So the overall mean of all the data points in this system is shown as x double bar is equal to 1 plus 2 plus 4, that is the sum of all these in cluster 1 and the sum of the data points in cluster 2, and divided by the mean divided by the total number of data points, which happens to be 2.5. So which evaluates to 2.5. However, the mean of each cluster, which is represented as xc1 bar and xc2 bar, which is 1 plus 2 plus 4 divided by 3, 4 is equal to 2.3 for xc1 bar, and 1 plus 2 plus 5 divided by 3 equal to 2.7 for for cluster 2. So SST, which is the sum of the square of the distance from each point to the overall mean, is got by subtracting from by squaring the difference from summing the square of the distance from the overall mean to each point in the system, that is 2.5 minus 1 squared plus 2.5 minus 2 squared plus 2.5 minus 4 squared plus 2.5 minus 1 squared plus 2.5 minus 2 squared plus 2.5 minus 5 squared, which computes to 13.5. The SSW, which is the sum of the squares of the distance from each point to its cluster center, is got by subtracting, or rather squaring the sum of each point, the difference of each point to its cluster center, And in this case, we evaluated the cluster center to be the same as the mean of each cluster. So we have 1 minus 2.3 squared, 1 minus 2.3 squared, plus 2 minus 2.3 squared, plus 4 minus 2.3 squared, plus, for the second cluster, we've got 1 minus 2.7 squared, plus 2 minus 7 squared, 2.7 squared, plus 5 minus 2.7 squared, which is 13.3. So this is the SSW, that is the distance, sum of the squares of the distances from each cluster to its sum of the square of the distance from each point to its cluster center. Finally, the sum of square of the distance between clusters is the sum of squares of the distance from overall mean to the center of each point in all clusters. That is given by x double bar minus xc bar minus xc1 bar squared times 3 plus x double bar minus xc bar squared times 3. Now we multiply this by 3 because we have to find the sum of square from the overall mean to the center of each point. So the center of this point is 2.3. So similarly, the center of this point is 2.3. So we've got to measure the sum of the squares from the center of each point. So this has to be subtracted from the overall mean. So 2.5. So 2.5 minus 2.3 squared, and we do it for each of the points. So we multiply it by 3, and then the same thing is repeated for the distance from 2.5 between 2.5 and 2.7, which is the center of the second cluster, and we multiply it again by 3 because there are 3 data points in cluster 3 as well. So this happens to be 0.17. So if we observe carefully, we can see that the sum of square of the distance SST is equal to 13.5, which is equal to SSW plus SSB. So that completes this segment of the video.